Good day, my name is Richard and a warm welcome to Tutoring with Richard, where we cover native topics. This channel is not monetized, which means we do not get any income from YouTube. Help us create more and even better content that will help you to pass. Consider supporting me by making a donation to my Capitec account. Other options are Snapscan, PayPal, Patreon or Buy Me a Coffee. Any amount is welcome and links are in the description box below. Today we're going to cover Mathematics in 6. The topic of this tutorial is centers of pressure on a vertical plate in a liquid. The question is included in the video beginning and end screens. We have been asked to issue a cautionary note. When doing these questions, please use the method I'm going to show you, as this is the method that is marked correct. Using your own method to answer questions could cost you marks, even though your method and answer might be right. See the cautionary note at the beginning of the video. On a side note, watch until the end of the video. If you watch only the first 5 minutes, you will not gain a full understanding of what you need to do. There is no quick fix in mathematics. It takes persistence, discipline and repetition. You have to use these steps in order to succeed. Let's get straight into it. Now, our question states, a vertical sluice gate is 5 meters high, 6 meters wide at the top, and 4 meters wide at the bottom. The top of the sluice gate is 1 meter below the water surface. Calculate the depth of the center of pressure on the sluice gate. So, what we basically have is here is our Cartesian plane, and here is our sluice gate. There's 3 or -3, and here is 3. Right, now we go from there to there. That's cut directly in half. Now we go 1 meter down, so that's at 1, -1. That's at -1. Now it's 5 meters high, so we go to negative, and then we draw from 2 until 2. We draw 2, 2 because it's 4 meters wide at the bottom. Then we connect, and that is our sluice gate. Now our points that we are going to use are on this side. So we're going to use 3 and -1. And here we are going to use 2 and -6. That is how we are going to use it. Now, what we need to do is calculate. So, this is 2, that's second part of our coordinates, and there's the first part of our coordinates. First things first, our formula to get our basic straight line formula, because we want from here, we want the point there to that point there. That straight line formula, we will need it. So how we're going to get it is y minus y1 equals y2 minus y1 over x2 minus x1 times x minus x1. What we have here is y minus minus 1, y minus minus 1 equals y2 -6 minus minus 1 all over x2. x2 is 2 minus 3 times x minus 3. So, what we are going to have here is -6 plus 1 is -5. -5 and 2 minus 3 is -1. and y plus 1 is there. So now we have times x minus 3. So that's 5. Y plus 1 is 5x. 5 times 3 is minus 15. So our formula, in a nutshell, now all we have to do is make it y is equal to. So move this 1 over, it becomes minus 1. So our formula, as it stands, is y is equal to 5x minus 16. With all our given information that we are given. So, now, to get our, now we've got to make it equal to x, because it's always best doing it with y. Because we need, the formula we will need is the integral of y squared. This is to find the center of pressure. They asked us to find the center of pressure over y. And this is the center of pressure. That is our center of pressure formula. So we're going to have to use this one and that one. So we need y. So you can't use y is equal to, so you'll need x is equal to and then dominate with y. So y equals, that formula comes at the end. So now what we'll do is y plus 16 equals 5x. Divide by 5, divide by 5, divide by 5. Right. So, all we are left with is that. So, first formula is the integral of minus 1 and minus 6. We'll use these two here. Minus 1 and minus 6. Y times 2x, which gives us, so this y 2x is equal to dA. We mustn't forget that. So we multiply everything by 2. So x is going to be this. So our formula is y over 5 plus 16 over 5. Now, times 2, the integral of minus 1 and minus 6. Now, y is equal to 2 over 5 y. 2 times, that is 32 over 5. It's 32 over 5. Now we put our y in. So that becomes y squared, and that becomes y. We can integrate. Okay, that is the first step. So now our second step is to integrate. So 2 to the 5th times 1 over 3 y cubed plus 32 over 5 times 1 over 2 y squared. So, now let's put it all together. 2 over 15 y cubed plus 32 over 10 y squared. Now, we can divide by 2 we can divide this by 2 and get 16 over 5, which I think we should do. 16 over 5. Right. So now, minus 1 and minus 6. Next step is putting our values in. 2 and 15 times negative 1 to the power 3 plus 16 over 5 times negative 1 to the power 2 minus 2 over 15 negative 6 cubed plus 16 to the 5th times negative 6 squared. And our final number comes out, it equals negative 83,333 meters cubed. Now that's important for the next step. Now, what we're going to do, now we're going to say the integral of y squared dA. So, the integral now, we're going to put this over here, minus 83,333 recurring meters cubed. So, integral minus 1 minus 6 y squared times 2y to the 5th plus 32 over 5 y. 32 over 5. Just plain old 32 over 5. Now, we make it y squared. So, the integral of minus 1 and minus 6. Now, 2 to the 5th y cubed plus 32 over 5 y squared. So, the next step. Our next step is going to be to integrate. Integrate minus 1 minus 6. Let's integrate. 4 times 5 is 20. So 2 over 20 y to the 4th. Let's put that in a bracket. And we will say plus times 3 is 32 over 15 y cubed. And that is our sum. Now we just have to put our values in. That's 1 over 10 times negative 1 to the power 4 plus 32 over 15 times negative 1 cubed minus 1 over 10 times minus 6 to the power 4 plus 32 over 15 times minus 6 to the cube. Okay, and this answer comes out to 329,167 meters to the power 4. Now is where that formula that I showed you in the beginning comes into play. Okay, so the formula goes, the integral of y squared over the integral of y. So, what we have here, this is y squared and that is y. So we have 329,167 divided by minus 83,333 meters cubed over meters to the fourth. Now this will just create meters. This will just create meters. So once that's done, now we put this in our calculator and we get minus 3,95 meters. Now the negative means that your center of pressure is underwater, which is obvious because we said when we did the graph that the sluice gate was submerged 1 meter below the surface. So where is our center of pressure? Well, this is our center of pressure here, which is, the symbol for that is Z with a line across it. If you found this tutorial helpful, please give it a like and subscribe. Positive feedback is most welcome. If you would like to help us make more videos like this, consider supporting me via donation to my Capitec account, Snapscan, PayPal, Patreon or Buy Me a Coffee. Links in the description box below. Be at peace, be kind to each other, and remember, passing well is achievable. Have a great day. Looking forward to seeing you in the next video.